Hello, everyone. Hope all is well. All right. Hope everyone is doing okay. Hope everyone's in good health as well. All right. I'm doing all right, in case you care. So let's go on. Some people had some questions on the review sheet, so let's go and look at that right now. Okay. Let's see here. All right. Number 1 and 2. You're just in number 1, you're just adding two functions, and number 2, you're dividing g of x over f of x, right, and just simplifying. And number 3, it's a composition, right, f of g of x. All right, just to remind you what you're doing, and this is in another video, f of g of x, but all you're doing right here is we're going to go ahead and say, all right, f of g of x. Let's see. All right, that's going to be right here. So right here in this case, right, we have f of, now g of x looks like right here it's x squared. So we're talking about f of x squared, right, is what this is going to be. All right, and you can put it underneath there. I'm just doing this to save space right here. So the second step right here is f of x squared. Okay, next, f of x squared. Well, let's look at the f function. It says x cubed minus 2, right? This is what I'm looking at right here. So that means whatever's in the parentheses cubed minus 2. All right, well, we'll say right here, whatever's in the parentheses cubed minus 2. And what's in the parentheses right here is x squared. So now we have x squared to the third minus 2. Okay, so the new thing that's happening right here, this is the f function right here. This is just x squared right here. It's x squared cubed minus 2. All right, so that gives me 2 times 3 is 6. That'll be right there, x to the 6 minus 2. And we got it, okay? Let's take a look at the next one right here. Some people were having issues with the word problem. Basically, there's two different options right here for this word problem. All right, it says the original price is $30, right? Now, right here, you can either, first of all, apply 30% off and then $9 off from the, and then use your gift card for $9 off is your option 1, right? So it looks like option 1 is 30% off and then the $9 off from the gift card, all right? So in this case right here, if we're doing price is 30, first we have right here 30%, and then secondly, $9 off, right? So what we're going to be doing is we're going to say 30 is my original price, right? Now 30% off. What does that mean right there, 30% off? Well, that's going to be 100%, right? Minus 30%. All right. No problem. Well, 100 minus 30 is, of course, 70%, right? Which comes out to 0.70. So we're going to say 30 times 0.70, right? This is my 30% off right here that I'm signifying by saying 0.70. And then from right there, I'm taking $9 off from that. Okay? So you have 30 times 0.70 minus 9. You got to figure out what is that. All right, I'll let you guys figure that out for yourself. Option 2, right here, it says $9 off first and then 30% off. So we still have our original price right here, which our original price is right there, $30. But from there, I'm taking $9 off first, right? And then 30% off, all right? So and from there, we said 30% off is 0.70 of the original value. We take 0.70 right there, multiply that by 0.70. All right, so figure out what this is. I'll let you guys figure this out on your own, just simple arithmetic, all right? And you tell me what's the better option. Taking the percentage off first, then subtracting 9, or subtracting 9, then taking the percentage off, okay? Let's see here. And for 4, it looks like I forgot a number, sorry about that, but for 4, 6, and 7, let's see here. Let's do number 4 first, all right? It says, Number 4. All right, let's do it. Do we have to write here, are they inverses? Ugh, this thing keeps on happening. Are they inverses? So to prove they are inverses, to prove the functions are inverses. Okay, first of all, right here, we have to prove that f of g of x, composition once again, equals x. Then we also have to prove that g of f of x happens to equal x. Okay? All right, let's do it then. F of g of x is x minus 5 over 2. Okay? So now I'm going to take that x minus 5 over 2, and right here, I'm going to take this guy and plug it right into the g function. I'm sorry, right into the f function, right? This was g of x. Sorry about that. I'm taking this right here, plug it right into the f function. So it'll be 3 times something plus 5, okay? No problem. Let's do it. So what is that something right there? That is going to be 3 times x minus 5 over 2 plus 5. So it'll be 3 over 1 times x minus 5 over 2 plus 5, right? All right, that's right here again, we want this all right here to equal x. We're trying to prove that it equals x, basically, is what we want to do. But maybe if it doesn't, then it's not an inverse. We can stop, right? So let's go ahead and distribute. 3 times x is 3x. And 3 times negative 5 is negative 15. Over 1 times 2 is 2. Plus 5. Doesn't look too promising, but let's see. So we have to combine these two right here, this fraction to 5, right? Let's see if we can do that. Well, what I would have to do is I need to take 5 over 1 and convert it so it has a denominator of 2, right? So I can combine these two guys right here. Let's see, 1 into 2 is going to go twice, right? So 5 times 2 is 10. So we'll say 3x minus 15 over 2 plus 10 over 2. That's a 10. So let's do it. Okay. That ends up giving us right here. Well, we have negative 15 plus 10 is negative 5. So 3x minus 5 over 2. This is right here absolutely not equal to x. So guess what? We don't even have to do the second part of proving their inverses. This is not necessary because the first one didn't even work. We just write NO. Okay, or you can just say they're not inverses. All right, but it didn't specifically ask, are they inverse functions? No. Okay. Now, if you notice, 6 and 7 are a little bit easier than this one. This was like number 4 was a little harder. All right. All right, and the last part of the review sheet right here, which is going and graphing, right, is all we're doing. Let's take a look at number 11, since that's like a little bit more difficult. Let's see here. So we have y equals right here 2 times the square root of x plus 2. All right, we kind of went over this last week in the Google Hangout, if you recall. What you have to do right here is we need to come up with values right here that make my radical, what's underneath the radical, be a perfect square, right? So what does that mean? So remember our perfect squares, our perfects, let's call them, right? That would be like 0, 1, 2 times 2 is 4, okay? 3 times 3 is 9, all right? Numbers like that, right? Those are perfect squares. So let's see here. Underneath the, what x value would turn this, underneath this entire radical, turn it into 0? Well, x would have to be negative 2. So we can use negative 2 first. Then what other x value can I put in here that will turn this into positive 1? So basically what you're doing, you're actually doing algebra in your head. X plus 2 equals positive 1. What number would that be? Well, that would be negative 1, right? And then what about 4? That's a lot easier, right? We're trying to figure out, we want this guy underneath there to equal 4. Well, that would just, of course, be 2. All right, let's stay with this for right now. Good enough. So we're going to go ahead and simplify this. So first we have 2 times the square root of negative 2 plus 2. That will equal 2 times negative 2 plus 2 is 0, the hero. And the square root of 0 is just 0, so 2 times 0 equals 0. There we go. Then next, right here, it looks like we have for x equals negative 1. That will be 2 times the square root of negative 1 plus 2. Negative 1 plus 2 is 1, so 2 times the square root of 1. And square root of 1 is this 1, so 2 times 1 just equals regular old 2. And for x equals 2, that will just be 2 times the square root of 2 plus 2. That's going to be 2 times the square root of 4. And square root of 4 is 2, so 2 times 2 just equals a regular old 4. All right, so that gives you 4. And there we have our t-table completed. So we have negative 2 comma 0, right? This thing is annoying. Negative 2 comma 0. Negative 1 comma 2. Over negative 1 up 2. All right, and if it helps, just go ahead and fill this in, right? Maybe fill in a couple of values there so you can see a little bit easier. And then we have over 2 up 4. All right, now, right here, and don't get confused, that's just part of Microsoft Word. Okay, so right here, we're going to go ahead and, there we go, and it keeps on going to the right, all right? It will go to on the x, right? It will go up. You can plug in, for x, you can plug up all the way, 100, 200, 300, all the way to infinity. To the left of negative 2, it doesn't go anymore. We'll stop right there, right? Because right here, if we have like negative 3, for example, that will be negative underneath the radical. That's going to give us an I. We don't want that. So this is your graph right here. And we are all good. So, all right. Go ahead and try the rest of the review sheet. See what you think. Hopefully it will go okay. And we will be all good. All right. Talk to you guys soon. See you later.